So the second package we're going to use today is the ggplot package. And GG means grammar of graphics. You will see in a few hours at the end of the session why it's called grammar of graphics. So to install a ggplot package, it's simply again, let's copy and paste this one, copy this one and put it here. ggplot, select the row, Control Enter, you send the row to the console and it will automatically install the package. We'll first look for it and find it. And if it's not working, no, it's ggplot 2. Sorry, my mistake.
Is this supposed to take forever? Because it's taking forever.
It's not supposed to take forever, indeed. But if you most GUIs have it already installed here, so you can simply click it here, and it's then added to your.
I started when you mentioned the dplyr thing, and it's still working to install.
The dplyr. Are you connected to the internet?
Yes.
Oh no. Sure?
Yes.
Okay. Shouldn't.
Ja, dit is een zelfverstand.
Ja. Oké.
Hij zegt dat hij alles gedownload heeft en blijft vervolgens hangen na een aantal dingen successfully aanpakt en die timestamps checken.
Echt hangen, ja. Dus hangen.
Nou, niet zo hard.
Heel open zo.
Maar hij is wel toe aan. Gewoon wat langer op kou.
Ja. Okay. So you can either choose. So you can either choose to select here the ggplot and dplyr package, or you can simply say library, in this case dplyr and library. Note that if you do the library function, you don't need the quotes. So this works with the quotes, it doesn't work.
Is there a difference in R between single and double quotes? For the install packages thing?
No. I have to think about no. There's not. My version of R maybe need to update. The last package that we're going to use today is the New York City database package, and that's a famous package. I'm going to show you the package. It's in New York City flights. Package.
En waar is flights 1.3?
Yep, 1.3. So there's a package called New York City Flights, and it contains all the airlines and data that are departing from New York City as a city in 2013. And this is the famous package that's used in to do some basic data science things.
All airports in New York.
Yeah, got 3 airports. So you get back to here and then install the packages. And it's called New York City Flights. Yep. And again, you can library. So, good question. This is the first part here is to install it on the system. So it's idle, not in memory. It's installed in the system. It's like you install Office on your system, but you don't run Word. The library part is putting it into memory, so you can use it. That's the main difference.
So sometimes it's advisable to switch off certain libraries because you get memory overload.
Yeah, you get memory overload, and sometimes you can imagine having the same function name in different packages, and that's annoying.
Namespaces.
Yeah, you get namespace problems, but you can define namespaces in R, and then but we don't go into namespaces right now.
Following objects on mask from packages.
Yeah. So what you see is, for example, here it says the following up marks to the package stats. It's a statistic package. It contains the function filter and lag. Both functions are very interesting. I'm going to use it today. But in the stats package, you run them on vectors. In the dplyr package, you run them on data frames. So as soon as you pass the data frame to the filter or lag function, R automatically switches the basic stats package to dplyr package. So it knows which function to use based on the inputs value. Like here, union, intersect are used from base.
If it says to do this several times, doesn't it cost a lot of memory?
What?
To switch from one system to the other?
No, it's optimized.
Okay.
You don't need, have a lag from it. No, good question. Okay, so active in memory, I have now these packages. On your serve drive, there is this data set, which I added. Data set for engineers, data sets, World Bank. So I added several data sets here from the country data information. And we're gonna first start with the to import this file, wdis wdid data long.csv. So how to import a CSV file in code in R? Well, given the fact that these CSV files are the most commonly used files to import, R has some tricks for you, because you can simply open here, import dataset, and RStudio will help you out a bit. It will generate. So, if you browse for a file, you browse to the data science for engineers, datasets, World Bank, and now click on data long and open. You will see that automatically R will generate code based on what you like macros in Excel. So it adds to the memory the readr package and will generate a table called WDI data long. What's long I will mention later on in the session.
Je moet even stoppen, want als je het op de server doet, moet je nog iets installeren.
Ik weet wel waarom je long heet.
Nou,
Maar dit gebruikt dus toch readr onder de.
Ja. And what you can do is either simply copy this code and cancel and then add this to the here and run this, or you can simply click on the
Alright.
Ja. Je zit echt niet aan het denken van de apart, maar.
Zie?
Nou, je komt nu in als je die server hebt.
Ja, joh, nou is hier.
Ik heb gewoon hier zitten kijken.
1 second, I'll pause this.
Ik weet niet meer uit waar.
So this readcsv function is the most basic version of reading a CSV file. There are new packages which I personally use. It's fast read and fast write, and what it will do is do reading in parallel. So I have a data set of 220 million rows, and I can read it in a few seconds because it's reading in parallel on my server on 64 cores. But it's interesting to see what you can do with this function. So this is the file, this is the delimiter, and you can specify all kinds of specific properties of your CSV file. Call names true says something about whether there are headings. Your location, you can set a function what to do with an NA value. So how is an NA value specified in your file? You can sample. You can run it on all sessions. A lot of possibilities. You can even do it on streaming data to read chunks, and if chunks are added to your file, to only read the added chunks. But as you might imagine, there's a lot of more options, like read from Excel, read SPSS, and you can even connect to databases or APIs to get open data.
Can I read directly from the serial port, for example?
Oh, good question.
There's probably some package.
Yeah,
Yes.
there might be a package to read from.
On-prem somewhere.
Yeah, good question. Okay, what did it add to your data, to your environment? A data set containing almost more than 250,000 records of 7 variables. So again, and R will try, as usual, to directly select the right class of object type to this data frame. So it sees that this is an integer, country name, country code, indicator name, indicator code, all characters, and this is an integer, and this is numeric. Yeah, so it tries to guess the right type of data set. Now this is the long version of the data, and as you might have seen, there are 2 versions in this data set: the long version and the normal version. I created the long version myself. And my first question to you is, why would this be the long version? And let's first take a look at this data set. So I do head, then the data set. Let's say, for example, show me the first 25 records. Or maybe we can better open it here. And make it.
I think it's long because it's not factored.
So it's long because that's factor.
So that we have a lot of duplicate values.
Yeah, duplicate values. It's almost what I expect as the right answer. So
it also depends on the end goal, right? Because I think the column value an indicator code says very little, and maybe you don't need those columns.
Yeah. So your answer would be this corresponds with this one. So this one is kind of double redundant, and this is the value which corresponds this to both of them as well.
Yeah, and the variable they have all 1960, so I'm not sure what.
Let's take a look. Let's walk through this data. So this is the country code, ARB, Arab World, 1960. If we proceed, we see.
Unique on the value.
So this is Luxembourg, and it's 1960, and this is some indicators. And if I go more deep into this data set, we might see different years. Let's see. Yeah, 1961, Europe, with specific indicators. Why would this be a long list? A long data frame? Maybe, yeah?
Yeah, it seems that some variables are inserted as observations.
Yeah, indeed.
Manually insert.
Let's import the other data set and let's look at the difference. So import CSV and let's import the data sets, World Bank. This was the long version, let's import this one.
Which ones?
The WDI data.csv. Ja, als je de server werkt moet je hem even uploaden. Hij staat gewoon op serverdrive.
Ik heb hem van SurfDrive. Ik heb hem via de SurfDrive webinterface. Daar staat hij niet.
Ja, nee, ik ook niet.
Nee, je hebt geen data.
Klopt.
Nee, het is niet gesynct.
Het is wel niet gezien bij jou, denk ik.
Dat is gek. Hij staat in de zip-file.
Oh,
Ja, inderdaad.
ja, die CSV.
Dat is uitgepakte zip-file.
Ja.
Staat hij erin?
Nee, maar dat is de
WDI data.
Maar een chef dat hij een chef kan niet kan openen.
Nee, de archive files found.
Ja,
zip is geen goede zip.
0 KB.
Heel gek, want hier zie je dat die mij echt toch al 61 megabyte is.
Is die niet gezien?
Deze is wel gezien. Nee, deze is ook niet gezien. Dat is gek. Wacht even zo. Even kijken of mijn surfdrive gaat zinken.
Oh, nu is die ook al weg.
Ik ga nu een sync forceren, even kijken of dat werkt. Je kunt de data ook vinden op de World Bank data. Het is deze. Deze is het. Ja, dan kun je hier WDI kun je downloaden. Ik maak eventjes een CodeShare pagina aan. CodeSharing. .io.
Data rond in org en bereiden even voor.
Als je naar deze pagina gaat, https CodeShare en dan A13Q hoofdletter RM, dan kun je tegelijkertijd bij mij in deze pagina editen. Dan kan ik de linkjes en de code gelijk inzetten.
Nog een keer, alsjeblieft.
Wacht,
Codeshare.
ik stuur het eventjes via colleges.
Codeshare.com.
deze link. Via Slack komt dit nu eraan. Je kunt nu allemaal werken in deze pagina. Hier ga ik ook mijn code plaatsen, zodat jullie die code gewoon kunnen kopiëren en plakken.
En dan is het weer de ICSV.
Ja.
Ja, zonder.
Welke moet ik dan hebben? De CSV-zip?
Ja.
Ja, plakken.
Resterende tijd.
Gaan we vrolijk allemaal de World Bank hammeren.
Dan ligt de World Bank er ook weer uit. Ach, geen probleem.
Als je dus een boek organiseert met zo krijg je CSV wel. Maar nee, kijk je natuurlijk niet serieus anders.
Hoe vaak had je dan nog de server?
Even kijken. So, in my case, there's two. I have two datasets in my memory. This is the long version. This is the normal version. This one has 7 variables, 250,000 records. This has 63 on 450,000 records. One is long, one is wide. My first question to you is, why is something long? What does it mean to be long? What does it mean to be wide? You can give me the answer by simply looking at the structure of the data. This is the data, and this is the other data. You can open the data by clicking on it here, and the other data set you can click on.
The long version doesn't contain any not available.
So the first thing is that long does not contain not availables. Okay. But let's stick. So this is country name, country code, indicator, code, variable, and value. And here you see country name, indicator name, and here you see years, NAs, and further some data. What happened? What's the difference between
You've turned different variables into
Observations into variables.
I turned observations into variables. And you can switch between them. So, the first thing I want to teach you today is what kind of data structure do we prefer if we do data science. And apparently, Sharaf already did the course Cleaning Data in R. No?
But what you do is you do an unpivot in Excel terms.
It's not a pivot. It's exactly the same amount of data. So here you see indicator, year, value. Yeah? And in the other one, here we see the name of the country and not the year, but per indicator we see the years in the width, and then we see
Alle permutaties, alle combinaties van country name en indicator name bestaan.
Hier zie je dat hij geen data heeft.
Dat was mijn eerste vraag.
Ja, dit heeft geen data.
Dat was mijn eerste
Ja.
vraag.
Maar omdat je, ja.
Ja.
Dus zo'n white table is vaak efficiënter in opslag, omdat je dus alles eruit haalt wat niet nodig is. Terwijl je als je het doet in een long is efficiënt, een white is, nou ja.
Deze white was efficiënter geweest als ook alles met not available eruit gestript.
Ja. Dan was hij nog efficiënter geweest.
Maar als je nu dan kijkt, wij snappen niet wat dan, als je nu dus in een regel kijkt waar wel iets staat, dan staat er 1.3 of 6.8. Wat is dat getal?
Dat is de value, dit is dus de volwassen birth rate van vrouwen die, nou, noem maar iets.
In dat jaar. Oh,
In 1960, 61, 62, 63. Ja, dus in de Arabische wereld, in die Arab world, this was the specific value. This is the value in 1961, 1962 for this indicator. In the long table, it's Arab world value, and here again the value of the indicator. But the important message here is that there's always two versions of the same data, the long and the wide. And dependent on the type of analysis you want to do, you use the long or the wide version. For example, if I want to do a time series analysis, then this is my timestamp, year in this case. Then you often use a long version because you want to, each record is a time observation. And if you want to do a statistical analysis for how does a country develop, given compared to other countries, you do wide version.
I'm sorry, I'm going to nag one more time. Is it correct that the long file does not have all of the data of the regular file, because the long file only has years 1960 through 1965?
That's kind of strange.
Well,
Because it's only in my, I simply took the data frame, made it wide.
this is what I did.
But is it because you see the table here, not the entire set, maybe?
Het zou kunnen, is wel gek.
I did a unique. Ja. En er is gewoon data in de normale datafile die niet in de zit.
Het enige wat ik heb gedaan is, je hebt een meld gedaan.
Ja.
Het zal,
I don't know what to tell you.
ja. Dat gaat buiten de...
Goed gecorrigeerd, ja.
Dat is wel gek.
Ja.
Want ik had...
Ja, klopt. Hij heeft niet al een jaar.
Nee, dat is wel raar. Ik heb dus een heleboel gekanteld en geëxporteerd om dit aan te geven. Maar goed, ik zal nog een keer exporteren.
Ja.
Vreemd? Ik moet dat het komt.
Are these the official name, the long and the wide?
No, what I did is a few hours ago I took the wide version. I melted, so you melt white into long. And you can, so this is called melt, and this is called gathering. Now what I simply did is I melted this one and exported it, because before we do any form of data analysis, we want to know in what form do you want your data to be to do an analysis. And so in the either last version, you have all years, all cities, all KPIs. And you want to do city KPI per year. And it's a different format for your how to do the analysis. Yeah? So the main message indeed, except for that you missed some years, strangely, is that you get a long and a wide version. And this is what we call an observation. And this is the variable. Yeah. And sometimes if you want to do a time series and your timestamp is a variable, and you get a value within a certain time scale, and sometimes you want to do this in white.
And which command did you use in R?
I'm going to show you later. The first one is first table is wide and long, and you need to know beforehand what your analysis will be and what format is your data when you import it? Yeah. Good, Ram.
How do you manage it?
Yeah, that's. I'm gonna at the end of the session we're gonna do the melting and the gathering. Yeah.
Oh, sorry.
No problem. Yeah.
Oh, yeah.
So observations, variables, and there's a package called tidyr, which helps you to tidy up data in a format that you want to have. Okay. Let's skip this one and this one, and this one. And this one. Now let's go. Let's leave it this dataset here. You can either do clean it like this, or you can use a command. The command to clean your whole memory is, where is my command? Yeah, indeed. Is rm list is ls. This is the co-sharing. This is the way to clean your memory in one command.
Why would you want to do that?
Because sometimes you want to rerun your analysis, clean the whole memory, and then run it again.
Otherwise, you might have variables with the same name and you mix up things.
Yeah.
Later on. So when I normally start programming, I always clear the memory and everything before I start doing something.
Het staat in de Slack, hè?
Oké,
Bij Kevin.
But then running the script again already gets the data again back from the.
Yeah, what you always should do is what I always do is make chapters in my script. So this is the chapter prepare system, and then the next chapter is prepare of gotta import data. Yeah. And what I always do is at the very beginning of my script, I always start with rm ls. Yeah. Clean memory, prepare system, and then add things to the system and import data. Okay. There we go. Let's get started with the dplyr package. If you run this code, excuse me, without the brackets, so this is the dataset of all departing flights from all New York City airports, and it contains several tables. What I did is I called the package New York City flights, double point, and then the function flights, and this is a dataset. So what I now did is run this code and add it to my data frame called data.
And what is the column or the two columns for?
It says take this package
Yeah.
and run this function in this package.
This flights is all.
Flights is part of the New York City flights package. Yeah? And it returns the data set of all data in this in 2030. Yeah.
So this data set is in white format.
That's the first question indeed. What format is it in?
White, right?
And it's in white format. Why? Because this is the variable, and if you would have this variable as an observation, these would have been labels of observations, each as a separate row. Yeah, it's a white format table. Dit is een naam van de observatie. Dit is het waarde daarvan. En anders zou je hem dus hier hebben als naam en als waarde en naast. Label en waarde. So what you see here is for each flight we see the year, the month, the day, the departure time. Note that it's a departure time is an integer, so it doesn't represent normal time. It shows the departure delay, the arrival time, the scheduled arrival time, the arrival delay, the carrier, so which air carrier is it, the flight number, the tail number, the origin, the destination, the air time, the distance of the flight, and a time hour stamp for this specific flight. Yeah?
So this is a data set which is already in the packet, right?
Yeah.
We also imported another one from CSV. Does R recognize the column names?
If the header is in the CSV file, then it recognizes the column names. And you can almost import any format. MySQL, JSON, XML, tar files, you can pictures, anything you can, well, videos, I haven't seen videos, but I can imagine you do videos as well. To watch video within RStudio isn't just the best option, I guess. Okay. So, the first step in the data science process is importing data. The second step is exploring the data. Data exploration. What does the data say? Anybody suggestion or anybody already know which function to use? Structure. So we can do. Yeah. Structure and then data.
Do you have like structure or STR is enough?
STR is enough. STR data. So what you then get is exactly what you see here. This is kind of the same what you see here, the structure.
It's called environment, but basically it's the structure.
Yeah.
If you fold out.
Yeah. And this is typically user interface, and this is doing. So you have to know that the RStudio is just an environment to program on R. That's why you should install both R and RStudio. I currently program in Jupyter, which is a different program. But you can even do command prompt programming on the Unix systems. Yeah, so it's up to you. You don't need RStudio. A second function you can use is head. And head simply, with a head function, you specify your data frame, the number of rows you want to see. Let's say 3 rows. Yeah? In this case, it shows me the name, the type, and it skips several columns because there's no more space in your environment.
The question is
Yeah.
also used view. View is not in one of our installed packages.
Yeah, view is view is capital indeed. And view opens the data in your environment.
No view.
But a better function to first explore the data is to draw summary statistics. And if you use the function summary on a data frame, it will do the following. I'll share this with you. Yeah. And let's take a look at what it says. So this is up. So it gives you the minimum, the first quarter, the median, the mean, the third quarter, and the maximum. So it's kind of a box plot. Yeah. What are the things we can extract from this function per column? Let's see. This one's not that interesting. The year, the month, not very interesting at all. First value is 1. The first quarter is 4. The median 7. The mean and the max is 12. So yeah, it's trivial. But if you look at the departure delay,
That's interesting.
there's already something interesting in the departure delay. Which elements are striking here?
The NH.
So there's more than 8,000 times there's not available in the departure delay.
You give a miniature of the negative value there.
And there's negative delay.
So it left too early.
It left indeed too early.
Max is also
We
very.
missed some passengers, but we don't care.
So this is already, so this is why you first do data exploration before we can, of course, we can now put anything in a naive Bayes model and predict any departure time of any flight without any care about what the data structure is. But we also could do some simple exploration. And for example, indeed, it is possible that there's a negative departure delay. So the aircraft departed before the scheduled time. The maximum value is in minutes is a lot.
So,
Is it more than a day?
These are minutes, what we're talking about. How do you know actually? Because with days you normally work in seconds.
Volgens mij is uit ervaring weet dat het dit is.
Ja, het lijkt me ook logisch.
Ja,
maar
it's in minutes. Yeah. So if we want to do an let's
En er zijn er evenveel met NA departure time als NA delay.
ja, dus die departure time
Iets met correlatie en causatie, maar
wat zijn er nou?
departure time, departure delay.
Ja. So if there's no departure time and there's no departure delay, what might be the case in this case if there's no departure time?
There's no actual departure time. There's only the scheduled departure time.
It didn't take off. It might be the case that this flight was cancelled. Yeah. So if we want to do an analysis on what's the probability of having a departure delay, we might. So this like previous week times. What's the probability of delay given the data? And the question question here is, what's the data? What is the data? Is it the data including
Dus,
all aircraft that didn't depart? Or shall we say, what's the probability of having delay given that the data and given that it did depart? Depart is true. So for a flight that did depart, what could be the delay?
a lot of planes have taken off, but they have never arrived. Because the arrival time is more NAs than the departure.
It's New York. It's not the Bermuda Triangle.
We can draw statistics on which. Okay. Let's see. What's more information here?
It's about the airports, not the two ends of the city.
Let's see. What can we say more? What can we learn from? Kijk op de mediaan en de mean te vinden. Ja. So there's a median of -2 and a mean of 12 by departure delay. What does it mean if the median and the mean are not the same? It's skewed. What does it mean if a variable is the distribution of a variable is
normally
skewed?
Not symmetric.
Could be either this one or yeah. Let's explore more in depth the departure delay.
In calculating the mean, it doesn't take into account the NAs, right? So does it score it as 0?
Let's do two things right now. Let's indeed try to. So, given that we are interested in departure delay, how can we? Indeed. How can we? So this is the data is the full data frame. Yeah, it's a list of factors, and now we want to access the factor. How did we do it? Dollar taken. So now we get access to the factor. In this case, we want to do depth delay. And note that if I, for example, do summary on this, I get exactly the same as we got here, but in this case I get it for only this column.
And we do a hist.
Yeah, indeed. If we do a mean, we get an error. Why do we get an error?
Because there's NAs.
Because there's NAs in the factor. How many? These. So if we do a mean on this factor, what we should do is na.rn is true. Remove the NAs before you do the mean. Yeah? Remove. Yeah. This is a standard code in R. What to do with NAs in a factor. And if I now run the code, it will show you this is the mean.
What do you do to immediately run the active line in the console?
Control enter.
Control enter. Oh, okay, I've been copy pasting.
Sure. Not needed. Yep.
Nou, je hoeft geen database. Je moet nu eventjes ga naar de pagina. Die gegevenen. Ik heb hem afgenomen, want hij staat hier. Die pagina, ga daar op bij. Eerst naar de pagina met de code share. Ja. Nu. Dit ga je doen.
Ja.
Later when you use the words in dplyr, there's also this way of removing the filtering out with this
function you can use this one with and other function you use.
Good question. Can we park this question for when we are doing dplyr? I will answer. I'll certainly answer this question. Yeah. NA remove is true. Okay, and this counts for not only the mean, but even if you can copy this to standard deviation, and it's the same thing. rm.na is true. Min, max, it's always the same element. Note that these functions, these are base functions. So from the basic R language, and they use factors. So I cannot use this. Will certainly draw an error. Why? Because I want to do mean on a data set. On what? So this is not the way to do it. Yeah? As Maarten already said, now there is something with this factor. And you can simply draw a histogram and visually explore this variable. Let's see, where is it?
I get a big bucket of errors when I do that. Vote.
Weet je zeker dat je dan kan je gewoon gemiddeld doen met heel veel. Ja, klopt, ja.
Een aantal regels selecteren. En dan doe je run.
Wordt dit ook in de vertragingen verwerkt, die negativiteit?
Ja, dat is de vraag. Berezen is de echte vertraging.
Even met Max eerst.
Ja, nee, maar dat is niet zo.
Dit is not available, and then remove.
Now, this is, so apparently there's an extreme value here, which skews the histogram to the right side. This may not be that interesting, and we know this value. Well, we know that this value is probably the max value, which was 1308. So what we could do is, might not be the best option, is say, okay, this, let's say, 1000 We could run this code. This will give us a list of booleans. Let up, dit is niet prefererend. And put this as a we could do this. So this is a list of booleans and make a histogram for all values lower than 1000. Now you will see that the histogram is up to 1000 here. Misschien is het beter om het naar 500 te doen. Ja, half traging oplossen.
Bijna alles gaat vroeger.
Hier zie je ook de eindelijk de negatieve values verschijnen. Ja? Nou.
Waarom is dat niet preferred?
Omdat dit, het is makkelijk. Hè? This is an easy way to quickly do some analysis. But the combination with dplyr and ggplot is, this is quick R, like bam, do some simple exploration. If you do in-depth exploration, for example, the title of the graph is not that great, so you have to add a title. This axis is not that great.
That's a quick and dirty one.
It's a quick and dirty one. It's simply quickly explore the data.
Why did you use the, is it called a semicolon or the haakjes? Zeg maar?
De haakjes.
Yeah,
Deze.
why can't you just say hist, haakje openen, data, dollar depth, and then smaller than 100? Why
Dan
do you...
krijg je een logical.
Dus deze bedoel je.
En dan krijg je niet meer logical. Je kan de vector van logicals doen gebruiken.
Ja. Dit werkt niet.
Maar nee, ik bedoel dus dat hele eerste stuk eruit. Wat krijg je dan?
Oh, dit.
Ja, dus dat je dat gelijk. Ja, dus alleen maar dat je alleen dat zegt. Wat je nu zegt.
Dit.
Ja, precies.
Ja. This, what R does here, is it compares each value in the vector with 100. And gives a boolean, so true, false, for each value. So now you get it indeed, as Martin says, 2 bins with true and false with the number of items. What you want to do is per position, you want to say, okay, this, show me this one, don't show me this one.
Okay, alright.
Yeah?
So the right code was again that you put it twice and then.
Yeah. Yeah? Okay. We can indeed, if you want to know how many flights we delete, note this is a list of booleans. Ja? Na de pauze help ik je even op weg hoor. This is a list of booleans. In R, it's very smart, in Python as well, a boolean has a value under the hood. It's for false means 0 and true means 1. So to know the number of flights that have a departure delay less than 100, we can simply say, give me the sum of this array with booleans. Want true is 1. Ja, dus. Oh. Sorry. Weggehaald. Ja, dan moet ik hem andersom doen. Dit is hoeveel er wel zijn en dit is hoeveel er weggehaald zijn. Yeah? What I here did is, this is an array of booleans with larger than 100. This I want to sum.
Je doet nu groter dan kleiner dan, dus gelijk. Je moet weggegooid.
En dat schelen er zo'n 150, om die wat gelijk.
Door de jet gelijk.
Ja.
Ja. So, back again, this is a wide data set with all factors in the data, and we can do factor-based calculations simply on this data set by accessing the factor with a $sign and do these calculations. Now, if we would only use the base package, we would have a hard time doing data science. Luckily, we've got dplyr. And dplyr has several commands. First one is select. Select. It has filter. It has arrange. It has mutate. It has group by and summarize. These are the basic functions within dplyr. It has some more functions, but the most important ones are these. Don't run this code, because it won't do anything. Another important element of dplyr is the pipe. And I love the pipe. The pipe this is the pipe. What the pipe simply does, if I have function a comma b, whatever function this may be, this is the same as a pipe function b. It's exactly the same. So it takes the argument that's here and puts it as first argument in the function. So normally we would do, for example, we would do select, then here say data, comma, and select columns 1 up to 3. So it selects the first 3 columns in my data set. Yeah? This is exactly the same code as data select 1, 2, 3. Exactly the same. Why is this important? Now, if we want to, for example, select data and then filter the data, without the pipe, you would have done filter, select, and do some filterings, blah, 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 blah.
Instead of 2 parentheses and a comma, you now do 2 percentages.
And now I do filter, and again, blah, 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 blah. So, because the compiler always takes the first argument and goes, and then it is first selects, then filters, and if you do more calculations, you get a reversed order of calculation. So if you select, filter, and then do a sum, and then do a group by, you get the order the other way around. Using the pipe, you have data, select, filter, and any comments thereafter. This is the main advantage of R above Python. The readability of this code is unique.
Because you write in the sequence that you want to
Okay. Well, Excel works like that to select that.
Could be.
but it's also functions in functions.
Yeah.
And you don't have intermediate tables or
No.
data. So that's also.
In memory, it's all temporary memory. So as soon as this function is, takes over, it removes memory and goes and proceeds.
Detailed question, can this also be used for multi-threading on a multi-core system?
Yeah. You can. This evening I spinned off 32 cores for on my own server. I can say my own server. You can spin off many cores, and it works with. It's called multi-dplyr. So you psoc an environment, put the libraries in there, do calculations, and then bam, and collect the results. It works great. I can show you the code in the class. Yeah. Now, what we so the select function the question mark select. So the select function simply does selection of data. So I give an example. You can do it by name of the column or by reference of a number. So if I want to select column 1 up to, in this case 3, I simply run this code and you will select the first 3 columns, as you can see here. Yeah. I can even make complex factors like 1 up to 3 combined with 7, 8 and then 12 up to 50. Now I create this is a function. It creates 1, 2, 3, 7, 8, 12, 13, 14, 15.
Do you not want a comma for the...
Oh, sorry. Nee. Ja, toch? Ja. Kan ook zo, ja. Yeah, so this function here concatenates 1, 2, 3, makes a 1, 2, 3, 7, 8, 12, 13, 14, 15. And I can now select these tables. I have to select these column numbers, and you get these columns as a result. Yeah? But you can also do it by name. I'll share this date in the wrong one. Like here. But you can also say, okay, do it by name. Like, give me the year and the day. It gives you year and day. Note, you don't have to specify this within quotes.
Or use data dollar.
Yeah, no, you don't have to. This is indeed the same as concatenate data year and comma data thing and make a list. Yeah. So the select function is a very easy function to do a selection. Note that I run this code, but I don't save the result. I simply run a code to do some data exploration. Oftentimes you don't need the result. You want to get a grip of the data. What does the data say? You can simply, of course, assign result, for example, to data 2. If I run this code, I get a new data frame here with 2 columns with the same results. Yeah. Now, in this case, we filtered the data, this case, with we took all data with a depth delay shorter than value 100. And you see there's a lot of repetition. Take this data frame, select this factor from the new created factor of the data frame with the factor, and do the calculation. Now, this is not kind of practical, and it's easily replaced by the following statement. Take the data frame, do the filter, and say depth delay is shorter than. This is exactly the same as this part within the bracket. I don't create a histogram right now. The main difference is that the result here is not the factor, it's the whole data frame. So if I run this code, share the code again. You get a data frame with all columns, and it leaves out the non-used columns, the non-columns that I'm not able to show here. And I can simply assign, for example, this again to data 2. If I run this, I get a new data set, data 2, with this number of records, with the whole data set, given the filtering shorter than 100. Now the nice thing is that dplyr accepts, contrary to this one, accepts very simple filterings added. Like with a comma, I can say, give me a departure delay less than 100 and a destination is AMS, like this. I don't know whether it flies to AMS, but let's take a look. No. Like carrier UA.
But then both statements have to be true.
Now both statements have to be true. So the comma simply says, take both statements, they have to be true. What's the food? There's food, yeah. If you want to do, this is the AND operator. The comma acts as an AND operator. Indeed, this is the same as this, and these are the same.
Is that true for all the 5 parts? Or only there in the filter?
For filter it's true, but not for the base filter version. The OR operator is this. So if I replace this one with this one, it's give me a departure delay less than 100 or carrier, etc. And it obviously gives you a larger data set.
And if both are true, then it still selects. So it's not an or, either this or that. But
No, it's not a XOR, it's a OR.
One of the things that was entirely clear for me from the course is what's the difference between the single and the double ampersand?
Nothing. this is the same as.
No. Those are quotes. I mean the and signs. Ampersands.
Welke bedoel je? Even Nederlands.
1 streepje, 2 streepjes.
Deze, oh ja!
Is het bitwise or logical? Or
Nee, dit is een heel gekke, maar dit is uit. So if you get.
The course was a bit fuzzy.
Yeah, this is. It's never used. It's never used. So if you have a factor here of.
Because the course wanted you to use that in some places.
Yeah, it's ridiculous. It's never. So this one says take A or the if this is a factor here, this is A C factor C larger than B, but only for the first element. This is this A or C1 larger than B1.
Okay.
You never use funky.
So returns a length 1 logical factor.
Yeah. Never.
Geldt ook voor de n.
Yeah. So like this is the same A and B. That's it. You forget it.
Maar het sneller als de lijst.